Am I audible? Anyone of you? $595. Am I audible? Am I audible? Anyone of you? Okay. let us start today's session because some more people have to join right now. Okay, we will start our session. Yesterday, we have discussed how to create the linked list and how to display the contents of linked list. Am I audible? Any one of you? Am I audible? Right. Now, in this class, we will see how to insert an element into the linked list and how we'll implement it, as well as how to delete an element from the linked list. So these things we will see in the today's class. Right. So as when you want to insert an element into a linked list, first of all, you need to decide where you want to insert it. Whether you want to insert in the first position or you want to be inserted any other position in between head and tail, where head represents the first node and tail represents the last node of the linked list. So, if you want to decide, if you decide you want to insert an element in the second position, as the diagram illustrates, the diagram was found to insert an element as a second node into the list. So, if you observe this diagram, here the temp is the new node where I want to, that is the element which I want to store it into the database, linked list. So, the temp consisting of data element as X, and the X which I want to be placed in the list at the second position. For that, what I have to do is, first I need to establish the connection between temp and the second node of the original list. What is the second node of the original list? That is B. So for that, I am supposed to write the code like temp dot next is equals to B. Temp dot next is equals to B. So once I establish the connection between temp and the second node in the list, after that I need to disconnect the connection between first node and second node of the original list. What is the first node in the original list? A. What is the second node in the original list is B. So I need to disconnect that connection and I have to establish a connection from first node to the temporary node which I was newly added to the list. So for that I need to write the code a dot next is equals to temp, so that the link will be established between these two, right? Right. In such a way, we can insert the element into the list at the second position. So similarly, the deletion also. So deletion also, first you need to decide which element or which node you want to delete from the list. So for that, first we need to establish the, suppose in the given diagram, the second node in the sense node 1, this is the node 1 and this is node 2 and this is node 3. Our list consisting of 3 nodes. Among these 3, I want to delete the second one. That is, which I was mentioned it as a target node. Okay. So in order to delete the target node, what I have to do is, whatever it may be the next part of the first node, okay, so that need to be connected to the third node. That is, node 1 dot next is equals to node 3. First I need to establish the connection in such a way. Okay. Automatically what happens? The connection between the first node and the second node is going to be disconnected. So whenever if there is no connectivity, you are unable to traverse it. As I told you in the previous class, when you are traversing the linked list, always you are supposed to start from the beginning, okay, and you need to traverse one after another. So how you are able to move from first node to second node? With the help of these address which is present in the next part of the node. So whatever the address which is present here itself, okay, you are able to move from here to that place based on this address only. So in this case, what happens is you have connected the first node to the last node. So in that case, what happens automatically? The connection between the first node and the second node is automatically disconnected. So when you are traversing the new list, what happens? What you have to done? Automatically, which is the first node. After that, it will be moved to the directly moved to the third node rather than second, because there is no connectivity in it. Okay, right. So that is deletion operation. Now we will see the two example programs: how to insert an element into the linked list at specified position, how to delete an element from the list. We will see with the help of an example, right? Right. So this is the code for inserting an element at a specified position. Inserting an element at a specified position. Okay. So first, let me execute this program, and then we'll see how it will works and all the things in the subsequent way. Just a minute. It is going to be executed now. Yeah. See, so this is the program. Are you able to view this? Okay. See, this is the code for creation of the node, as we have discussed in the last class. So with this, we can create a new node. This is the class. We can create an object to this particular one, so that a new node will be created. Right now, you all aware of that, how to create a linked list and all. Now let us focus on the insertion part of the linked list. Right. Right. So this is the part actually which was here. Insert is the code for creating the linked list, which I was recorded. So this is the code for inserting at a specified position. This is the code for inserting an element at a specified position. Insert nth. So for that, what I did is, let us look at about the main program. So here linked list ls is equals to new linked list, and after that I'll make a call to the method insert. So this insert method is meant for creation of the linked list. So initially I was created a linked list with the help of these three nodes. With the help of these three statements. So first it creates a new node, as we have discussed in the previous class how to create a linked list. First it creates the node with the value 10, and after that when you try to create the second node, what happens is, let us look at the code. If this dot head is equals to null, head is equals to null. So this will execute only when you are creating the first node. So remaining all the cases, it will execute the second part, right? So node temp node is equals to this dot head, while temp node dot next is not equal, next node is not equals to null. Temp node is equals to temp node dot next node. Initially we will assign both temp and head to the starting node. So whenever if you try to add the new element to that, we'll move, as we have discussed in the last class, we'll shift the tail node from first to second, so that it points the second node. And then when you're adding the third element to that, what happens in that case? So again the tail will be moved to the third word. So like that it is going on when you are adding number of nodes to the linked list. As you are aware of that, linked list, there is no size limitation for the linked list. Continuously it can grow. It depends upon your requirement. Whatever it may be, the number of elements which you want to add, you can add like that, right? So in this case, I was created a linked list with the three nodes. First node consisting of 10, the data value as 10, and the second node consists of data value 20, and the third node consists of data value 3. You can observe the output here itself, 10, 20, 30, and followed by null. So how you get the null? By default, whenever if you try to create a node, automatically the constructor will be executed. That constructor, what it does is, what it does in the last class I have shown you. So whatever the data that you have supplied, that was placed in the data part of the node, and by default the next part will be initialized with null. That is the job of the constructor. So when you are adding first node, the next part is initially it was assigned with null. After adding the second one, the address of the second one will be filled with the next part of the first node. Like that it is going on. After adding the third node, what happens is the next part still it becomes null until you add the fourth element. Suppose if I write a statement like ls dot insert of 40. So what happens in that case? Again, another node is added. Now you will observe the null as a next part of the 40. All of you understand? 40. Now the new element is added. 40 is added, and the last position, I mean 40th, fourth node's next part is null. So in such a way, the list is going to be grown up. Now the point here itself is how to insert an element at a specified position. Specified position in the sense, if you want to add at the beginning, what you have to do? The first element. How do you identify the first element? Always the first element in the linked list is head, represented with the name head. Suppose if you want to add an element at the first position, what you have to do? What you have to do? Suppose temp node if you want to add. Okay, so you are supposed to write the code like temp dot next. Temp dot next is equals to head. Temp dot next is equals to head, because head is previously heading the first node of the list. Now whenever if you write the statement like temp dot next is equals to head, what happens in that case? The new node the new node dot next will be linked with the first node of the original list. Suppose if always the index will be starts with 0, let us observe the outputs and then we'll discuss about the code. Suppose 0th position. If I write the statement like I want to insert a node 25 at a 0th position. This represents the index. That means place where you want to insert, and this represents the value that the new node will contain. Okay. So in this case, I want to insert the element at 0th position. That means first node. I want to add the new element as a first node. So here, what will be the list you are supposed to be expect from after executing this program? 25, 10, 20, 30, 40 followed by null. So let us see whether it produces the same output or not. Right? The new element is added to the list, that is 25 at which position? First position, because this is the original list